When we're looking at a custom logic, it's probably once again good to strip ourselves back to the basic elements of computer software. And any computer program has its inputs, which are generally raw data, such as integers, string, and Boolean data types. So they're your main types of inputs that will come into a computer. And in order for them to be processed, they need to be stored. So if there's obviously just one input, then a variable or a constant is probably the best type of a storage for that. But if you start to get lots and lots of inputs coming into a computer system, then and especially of the same type, it's probably not as efficient in terms of programming to have a whole range of different variables, because obviously each variable or constant has to have a unique name in which to identify that. And one of the problems is you start to, or you end up working with too many different types of variables. So it's good to organize them in a in some form of structure so that they can be processed. And obviously once they are processed, that raw data is now turned into information, and that can be displayed, printed, and probably the majority of times it's stored in ROM. So if we have a look at an example here, and our focus of custom logic really looks at the use of data structures and how they're employed within a computer program. In order to solve complex problems, you've really got to organize your data so that it can be processed. If data is not organized adequately, then it will then slow down the processing of the computer system. So the example we've got here is a program is required that will find the average temperature for a week. So a week is 7 days, so we're looking at 7 temperatures. Obviously the processing would be calculating all of those temperatures together and then dividing it by 7. So one way in which to solve this problem is that I could actually have 7 different variables called day 1, day 2, day 3, day 4, day 5. As I said there before, that itself there gets a little bit complex and may be very difficult if someone else was to look at your code. There's a more efficient way of solving that, and that would be the use of an array. The reason array is selected is because they average temperature is all of the same data type. Now that's one of the main factors of using an array. So if we look here, I've got an example of an array. There are 7 elements within that array. Obviously we know an array must have its own name, which is unique. And it also must have an index, and we can actually pinpoint certain elements in this array. It's blank at the moment, so obviously this program would maybe ask the user to input temperature 1, and they use a text box, and maybe if they click the command button, it would store what the user had imported into that first element of the array. Then it would increment the index, ask them to do it again, so there'd be a form of repetition in terms of control structures. So it would continue to ask the user to input the temperatures. Now we would also have to have a variable that so once that all 7 had been inputted, we would then exit the loop maybe and then start another loop where it would grab each one of the elements of the array, add them all together, which gives us 152. That itself is a variable because that would change every time that this program is executed. We'd have to divide it by a constant, which is the 7 days. So obviously you're not the days themselves aren't going to change, so it's always going to be a 7, so that's why it's a constant. And that therefore gives you your answer, which is 21.7, and that's the average temperature. So what we're looking at here is an example of how an array itself is probably the most appropriate data structure that can be used. And this is an example that could be implemented in a wide range of different software solutions. That's why it comes under the hat of custom logic. It's something that can be utilized throughout a range of different complex problems. If we have a look at another example here, something that's quite current, a program is required for the Premier's flood relief appeal that record donations made online. So we're looking at, once again, recording information so that it can be stored or it can be processed So donations made online. We probably need a little bit more information to try and identify what type of data structure to use. But if we just look at it, that users themselves would have to record their name, how much they want to donate, maybe their phone number, and also to select whether they want to pay by PayPal or not. So if we get an example here, array of records would be the most appropriate data structure for this solution. Reasons being is because there's multiple data items, and the reason that wouldn't be a multi-dimensional array is because they are of different data types. So name would be string, amount would be integer, phone would be integer, and PayPal username would be Boolean. So whether yes or no, whether they're going to use and pay by PayPal. So if we look at this to be populated here, obviously, once again, in terms of control structures, we'd need some form of repetition that would allow the user to populate each index of the array of records. And as you can see here, 1 to 4, that's the array part that it still works as similar to a single dimensional array. They have a unique identifier. Along with the unique identifier, they also have a field that can be referenced. So you can actually pinpoint with an array of records record number 2 dot amount, and that would display 1,000. You could pinpoint record 3 dot PayPal, and that would print no. So you can actually drill right down into the elements of each record, and that's one of the benefits of array of records and reasons why they're probably one of the most commonly used data structures. Probably the last one, and it's probably it's probably too complex to explain here, but I just want to give you a snapshot of what a file is, and it's very, very important to realize that files themselves are used in which to store large amounts of data in ROM. So it's very, very important that when you take information from within a file, it's obviously got to be opened up and imported into a computer program. When it is often imported into a computer program, it's generally imported into an array of records. So there's a bit of correlation between a file and an array of records. But the essence of a file is that it is to store large amounts of data in an offline format. So when you're using files with encoding, you have to open them and you have to close them. So the opening is importing it into an array of records, and the closing is then sending it back to the hard drive or where else it may be stored. Thank you.